Hello grade 10. For today, let's have our review in a geometric series. So when we say geometric series, it is a sum of the terms of a geometric sequence. So ngayon, alamin natin paano natin kinukuha yung sum ng ating mga geometric sequence. So we have two classification of a geometric series. The first one is the finite geometric series, and the second one is the infinite geometric series. Okay, so sa finite geometric series, these are the sum of a geometric sequence wherein we have a finite number of terms. So ibig sabihin, given yung last term natin dito sa finite geometric sequence, kumbaga meron lang hangganan kung hanggang saan lang yung kukunin natin ng sum ng ating geometric sequence. And the formula of a finite geometric sequence, that is S sub n, is equal to a sub 1 times 1 minus r raised to n over 1 minus r. Okay? Wherein a sub 1 is the first term, r is the common ratio, and your n is the number of terms. Kung ilang terms ba yung kukuhaan nyo ng sum, that is your n. Nakuha? And sa infinite geometric sequence, meron tayong dalawang condition. It can be convergent and it can be divergent. So, kapag convergent yung ating geometric sequence, ang common ratio niya is less than to 1. Okay, so when the common ratio is less than to 1, that is convergent. But when the common ratio is greater than or equal to 1, that is divergent. And the common ratio should be in an absolute value. Nakuha? So kapag, let's say ang common ratio natin is 1/2. So that is less than 1. Therefore, that is convergent. But if our common ratio is equal to -2, that is -2, yes, less than 1. Pero sabi nga natin absolute value. So ano ba yung absolute value ng -2? That is +2. So kapag +2, that is greater than 1. Therefore, that is divergent. Nakuha? And tandaan, if we have a common ratio of 3/2, this is an improper fraction, tama? And alam natin, lahat ng improper fraction are greater than 1. Therefore, that is divergent. So, yun yung tatandaan natin na hindi lahat ng fraction less than 1. Yung improper fraction, all those value are greater than 1. Therefore, if we have a common ratio which is an improper fraction, that is divergent. But if it is a proper fraction, that is convergent. Ano ba yung proper fraction? Yun yung 1/2, 1/5, 1/3, 2/3, 2/5. Yung mas mataas si denominator compared kay numerator. Si improper fraction naman, yun yung 3/2, 5/2, 7/5. So, mas mataas si numerator compared kay denominator, that is improper fraction. So, nakuha. Tandaan lang, when the absolute value of the common ratio is less than 1, that is convergent. And when the absolute value of the common ratio is greater than or equal to 1, that is divergent. So, bakit nga ba natin kinaklasify muna yung geometric sequence natin kung convergent ba siya or divergent? Kapag convergent, tandaan, dito lang tayo gagamit ng formula ng infinite geometric sequence, wherein that is S sub infinity is equal to a sub 1 over 1 minus r. Nakuha? Kapag divergent naman, hindi natin makukuha yung sum ng ating geometric series. Therefore, the sum of a geometric sequence cannot be determined. Nakuha? So, the sum cannot be determined. So we cannot solve when we have a divergent infinite geometric series. Magsasolve lang tayo kapag convergent. Alright, let's have an example in a finite geometric sequence. So dito muna tayo mag-focus sa finite geometric sequence. So example number 1, let's get the sum of the 6 terms given the geometric sequence of 1, 3, and 9. Okay, so we're going to find the sum of the 6th term of this geometric sequence. So, identify muna natin ano yung mga given natin dito. The first term is 1. The common ratio is 3 divided by 1, or the second term divides first term, that is equal to 3. And our n, kung ilan yung sum, ilang terms yung kailangan kuhaan ng sum, that is 6. And using the formula of a finite geometric sequence, that is S sub n is equal to a sub 1 times 1 minus r raised to n over 1 minus r. Okay, so the first term is 1 times 1 minus the common ratio of 3 raised to 6. And you have here 1 minus the common ratio of 3. Then you simplify. 1 minus r raised to 6, that is, simplify muna natin yung 3 raised to 6. Okay, so that is, ilan? 3 raised to 6, that is 729. Nakuha. And you have here 1 minus 729 times 1 over 1 minus 3, that is negative 2. And 1 times 1 minus 729, that is also as 1 minus 729. Diba? So, alisin na natin yung 1. And 1 minus 729, that is negative 728. Over negative 2. And negative 728 divided by negative 2, that is 364. So, ibig sabihin, the sum of the 6th term of this geometric sequence is 364. Another example. For example number 2, let's say we have here, we are going to find the sum of the 9th term of a geometric sequence. Let's say we have 2, negative 4, 8, and so on. Okay? So again, let's identify first the given. Our a sub 1 is equal to 2. The common ratio is negative 4 divided by 2, that is negative 2. Our n, ilang terms ba yung kailangan kuhaan ng sum? That is 9. And using the formula, S sub n is equal to a sub 1 times 1 minus r raised to n over 1 minus r. Substitute the given. So you have here 2 times 1 minus the common ratio of negative 2 raised to 9 over 1 minus negative 2. Okay, so negative 2 raised to 9, that is negative 512. So you have here 2 times 1 minus negative 512 over 1 minus negative 2, that is 3. Diba? Change the sign of the subtrahend and proceed to addition. 1 plus 2, that is 3. Next, 1 minus negative 512, that is 513. And 2 times 513 is 1,026. And 1,026 divided by 3, that is 342. Therefore, the sum of the 9 terms of our geometric sequence is equal to 342. So, nakuha. So, all you have to do is to identify first the three given, the a sub 1, the common ratio, and your n. Then, after that, use the formula. Then, unahin i-simplify yung mayroong exponent. Then, after that, yung denominator. Then, after that, yung nasa loob ng parenthesis, yung 1 minus negative 512, which is 513, multiplied by 2, divided by 3, then you'll have your final answer. Okay, so let's proceed with an infinite geometric series. So let's have an example number 1. Let's say we're going to find the sum of the infinite geometric series of a sequence 30, 15, 7.5, and so on. Okay. So, identify muna natin yung common ratio when we are solving for an infinite geometric series. Okay, so common ratio is equal to the second term over the first term. So, that is 15 over 30. And 15 over 30, that is 1 half. And 1 half, kapag ang common ratio is 1 half, ano siya? Convergent, divergent. Okay, convergent. Therefore, we are going to use the formula of S sub infinity, which is equal to A sub 1 over 1 minus R. So, yan lang ang solution natin for an infinite geometric series kapag convergent siya. So, identify the first term. Ano yung first term natin dito? That is 30. Ano yung common ratio natin? That is 1 half. So, that is 1 minus 1 half. And 1 minus 1 half, that is 1 half. And 30 divides 1 half, it can be written as 30 divided by 1 half para di kayo maguluhan sa part na to. Okay, so dividing numbers. So, you just have to cross multiply. 30 times 2, that is 60. And 1 times 1 is 1 naman. Therefore, the sum of an infinite geometric series, of this infinite geometric series, is equal to 60. Nakuha. Let's have an example number 2. Let's say we have 3. We're going to find the sum of an infinite geometric series if we have 3, 3/4, and 3 over 16, and so on. Okay, so again, identify first the common ratio. The common ratio is 3/4 divided by 3. Kasi diba ito yung second term, ito yung first term. So 3/4 divided by 3, sige, sulat na lang natin siya as this one. So again, you just have to cross multiply when you are dividing fraction. That is 3 over 4 times 3 is 12, 1/4. Okay, so therefore the common ratio is 1/4. So is it convergent, divergent? Okay, convergent. Therefore, we have to use the formula again. S sub infinity is equal to A sub 1 over 1 minus R. Wherein the first term is 3 over 1 minus the common ratio is 1/4. 1 minus 1/4, that is 3/4. So, that is 3 over 3/4. And 3 divides 3/4. Again, sulat natin siya as this one para di kayo maguluhan. So, 4 times 3 is 12, and 3 times 1 is 3. So, you have here 12 over 3. And 12 divides 3, that is equal to 4. Therefore, the sum of this geometric series is equal to 4. Another example, number 3. Let's say we have our sequence. Let's say we have to find the sum of an infinite geometric series of 2, 4, 8, 16, and so on. Okay, so again, identify first the common ratio. That is 4 over 2, and that is 2. Now, is it convergent, divergent? Alright, this is divergent. So, the series is divergent. Therefore, the sum of this geometric series cannot be determined. So, ibig sabihin, walang solving na mangyayari kapag divergent siya. Nakuha? Ano pa example natin ng divergent? Let's say we have to find the sum of an infinite geometric series of 5, 25, 125, and so on. Okay, so ano ba yung common ratio nito? That is 25 over 5, that is 5, which is greater than 1. Therefore, that is divergent ulit, and the sum cannot be determined. Nakuha? So, wala tayong solving na gagawin dito. Kasi nga, it is impossible to get the sum of this geometric series kung if this sequence will goes infinitely. Nakuha? Kaya meron tayong divergent and the sum cannot be determined. So, I hope we are clear and we understood the topic about the geometric series. So, thank you for finishing this video.